Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. And today I want us to touch something very important in Shape and Space 6, and we'll be dealing with our book page, starting page 76, moving forward. We shall see exactly that we are required to talk about intersect chords. Intersect chords, some other pointers that we know, and for let us some of them have a chord like this, and there is a set radius is perpendicular to that chord. The radius is perpendicular to that chord. And of course, when we talking about perpendicularism, is not just that, because it bisects the chord into two equal portions. So if this is O and this is A and this is probably B, M, we are quick to note that AM is equals to MB. Now that this is a chord and this is coming from the center, meeting the chord at right angle and right at the center of the chord. So it bisects the chord into two equal portions. And having said that, I need to explain something to do with example 4, which is on page 76, and you'll be told that O is the center of a circle. The length of the chord is 18. OM is perpendicular to AB. Let me just draw the diagram here. O is the center of the circle. We are talking about A, B, which is 18 centimeters, and there is the point M there, just like what you've drawn here. Work out the length of AM. It goes without saying, if AB is equals to 18, AM happens to be half of AB. Because you can see there is a by, and it is exactly bisected to two equal. So AM is equals to 9 centimeters. It just goes without saying. It's 9 centimeters. Just because of the reasons that we have explained there. And I want to go further and explain something to do with intersecting chords theorem. And there are those chords that intersect internally. The chords, I want to talk about the chords that intersect inside a circle. And as such, I mean something like just this. That is a chord, and that is another chord. If we're talking about this is A, B, and this is C, D, and this happens to be P, then somebody may ask you that AP is 10. That is 10. We are answering now example 5, so that I'll tell you the details of chords that intersect inside the circle. AP is 10 and PD is 4. Let's talk about 4 centimeters there. PB is 6 centimeters. Find CP. Let's call it X. Listen and listen carefully. In case chords intersect internally, then AP times PB is equals to CP times PD. from one point to the point of intersection multiplied by that other point on the same, that other stretch of the same chord that remains, is equals to the other chord from the point of circumference to the point of intersections multiplied by the remaining stretch of the same chord. So what does this mean? AP times PB is equals to CP times PD, internally intersecting chords. What is AP? 10 times 6. AP 10 times 6 is equals to CP x times what? Times 4, or rather 4x. So if we rearrange this, we are going to find that 4x is equals to 60. If 4x is equals to 60, what is x? Divide by 4, divide by 4. X is 15 centimeters. So in other words, CP, which is x, is actually 15 centimeters. Please don't forget, if the chords intersect internally, then it's simply this way. Okay?